So if you're setting up a stage rig, especially with a lot of electronics,
Yeah.
multiple keyboards, maybe a laptop, a sampler, you know that feeling.
The dread.
The dread as loading gets closer, you've got, what, 4, maybe 8 different sound sources. They all need power. They all need MIDI. And worst of all, they all need clean audio sent to the main mixer, which could be like 200 feet away.
It is the ultimate logistics nightmare. I mean,
Sure.
you're not just sending 4 audio channels. You're dealing with 4 potential ground loops, 4 different signal levels,
Right.
and 4 places where interference can just creep in and completely ruin the show.
Yeah.
And that's before you even think about your own monitors.
Exactly. You need the front of house engineer to get 4 clean lines, but you need to hear a good blend of those lines yourself. Historically, that meant a little sub mixer and 4 separate DI boxes.
A lot of gear, a lot of
Yeah.
cables.
So our mission today is to do a deep dive into a solution that kind of combines both of those jobs into one unit. It's the DBXDI4 Active 4-channel direct box with line mixer.
hmm We've dug into the product description, the specs, the whole engineering philosophy behind it, really. And we're going to unpack how DBX pulled this off-professional signal handling and stage mixing in a box that's just half a rack space wide.
And before we get into all the engineering, let's
Yeah.
just frame the sheer utility of it. It does 2 jobs at once. It's 4 separate active DI boxes, and it's a stereo line mixer. And all of that in that tiny little package is currently going for about $170.
Yeah. That price point makes the engineering choices they made even more interesting to look at.
Totally.
So let's start with the most fundamental job, the direct box function. This is, the oldest problem in live sound, and it's the most important one to solve first.
So let's back up even further. Why is a DI box even necessary? Why can't I just run a long 1/4-inch cable from my synth straight to the stage box?
It really just comes down to the signal type. It's physics. Most keyboards, active basses, that kind of gear, they output what's called an unbalanced signal.
Okay.
It uses those standard 1/4-inch TS connectors,
Hmm.
and it's just inherently fragile. The second you run that down a long cable, that single conductor, it basically becomes a giant antenna.
Oh.
It invites every stray radio signal, all the hum from the lighting rigs, every buzz from bad power. It all goes right into your audio path.
The classic, terrible 60-cycle hum that haunts every single venue.
Precisely. So the DBXDI4, its primary job is to grab that noisy, unbalanced signal and just immediately transform it. Clean it up into a really robust, balanced output signal.
And that's what uses the professional XLR connector.
Exactly, the XLR outputs. By creating that balanced signal, which is essentially 2 mirrored copies of the audio with the noise inverted, the main mixer can then just cancel out all that common noise, leaving you with nothing but clean audio.
Okay, so let's get into the technical side of that. You're not just changing the plug on the end of the cable, you're fundamentally changing the electrical properties of the signal itself, right?
Oh. That's where looking at the specs gets really revealing. So the unit takes an input impedance of 320K ohms from your keyboard. That high impedance is pretty typical for instrument outputs.
Okay.
It then converts that down to an output impedance of 600 ohms.
And why is that drop, from over 300,000 ohms down to 600, why is that so important for a stable signal?
It's all about driving the signal over a long distance. When you lower the impedance that dramatically, you're basically giving the signal more muscle. You're increasing its ability to push current over a long cable without losing its quality.
So a high impedance signal just kind of runs out of steam.
It does. It loses high frequency detail and volume very quickly. That low 600 ohm output means the signal is tough. It's less susceptible to the capacitance of, 100 feet of mic cable. It's built to deliver.
So you're not just cleaning the noise, you're basically bulletproofing the signal for its journey. What about handling really loud inputs? Some pro synths put out a really hot signal that can clip an interface easily.
They definitely engineered for that. The specs show a max peak input level of plus 15 dBu, and the max output is plus 16 dBu.
And that's pretty high.
It's key.
Hmm.
Standard ProLine level is usually around plus 4 dBu, so having the headroom to cleanly handle a signal all the way up to plus 15 means those powerful high-end keyboards won't overload the circuits and give you that nasty clipping before it even leaves your rack. It's your safety net.
That headroom's important, but what if your input is too hot? Even for that, this is where the actual physical controls on the box become so important for a gigging musician.
Absolutely. The engineers knew you need control right there. That's why each of the 4 channels has its own independent 20 dB pad switch.
Mm-hmm.
If you're plugging in something really hot, maybe the output of another mixer, you just flip that switch. It drops the signal cleanly by a huge amount, prevents any overload, and it doesn't color the sound at all.
And then there's the other big one, the classic lifesaver for every venue, the ground lift.
Yes. The independent ground lift switch, we've all been there. You plug everything in, the power in the venue is a little sketchy, and you hear that awful, loud hum.
Sounds like a demon is chanting from your speakers.
It really does. That's a ground loop. It's a difference in electrical potential between your gear and the house system. The ground lift switch just safely breaks that connection inside the DI, kills the loop, and the noise is gone instantly.
And having one for each channel is huge for troubleshooting.
It's brilliant for diagnostics. You can figure out exactly which piece of gear is causing the problem.
Okay, so we've covered the DI part of its identity. It takes 4 messy signals, cleans them, stabilizes them, and sends 4 solid, balanced XLR feeds to the house mixer. Problem 1 is solved.
Right. But the musician is still standing on stage with 4 different instruments, and all they can hear is this sort of mush coming back through their monitor wedge, if they hear anything at all.
Exactly. So how does this box pivot from being a tool for the sound engineer to solving the musician's personal monitoring chaos? That's the stereo line mixer function, the whole second half of its identity.
And this is just genius for stage efficiency. The musician needs to blend their 4 sources into their own stereo mix for their in-ears or a local monitor, right?
Mm-hmm.
So instead of needing like 4 more cables going to a little monitor mixer on the floor, it's all consolidated. All your keyboards, your laptop, whatever, they all go straight into the DI4.
It just streamlines your entire wig into one little half-rack unit. But let's look at how that mixed signal gets to the musician, because the unit has 2 totally separate output paths, which is crucial.
Path 1, like we said, is the 4 independent XLRs going straight to the front of house. Path 2 is this new thing, the custom monitor mix.
Okay, and this is where I want to push back a little, because the specs say the stereo line mixer outputs are RCA connectors. Wait a minute, RCA? This is a professional DI box built for long-run XLRs. Why on earth are they sending the musician's critical monitor mix out on, consumer-grade unbalanced RCAs? Doesn't that risk adding noise right back into the system?
That is an excellent critical question, and it really speaks to the kind of compromises you have to make in a compact design at this price point.
Okay.
The XLRs go to front of house for that ultimate clarity over a long distance. The RCA outputs, they're really intended for very localized monitoring. Think about where that signal is going.
A short run.
A very short run to a little personal headphone amp or maybe an in-ear monitor transmitter that's sitting right next to the DI4 in the same rack.
So it's a trade-off. They prioritize the long run to the FOH engineer, and they used a less professional connector for the very short stage monitor feed to save space and keep the cost down.
Precisely. For most personal monitoring needs on stage, where that cable run is maybe a foot or 2, the RCA connection works perfectly fine. It's an engineered compromise based on how people will actually use it.
Okay, if we accept that compromise, the amount of control you get over that mix is pretty exceptional. It's not just a summed mono feed.
Absolutely not. This is where the musician gets all this control that the FOH engineer doesn't have to worry about. For that line mixer output, you have an independent volume control for each channel. And, critically, an independent pan control for each channel.
That pan control is a total lifesaver for in-ear monitoring.
It changes everything. I mean, if you're playing 2 keyboard parts that are fighting each other, you can pan your lead synth a little left and your pad sound a little right, just in your ears.
Right.
It creates mental space. The audience hears the main mix, but you get a custom stereo image that helps you perform better.
And there's a master volume for that whole mix. But my favorite little feature, the one that solves that quietly checking your patch before the show problem, is the dedicated headphone output.
Yeah, that 1/4-inch headphone jack is indispensable. Sound check's over, the house lights are down, and you realize you need to tweak a setting on your sampler. You just plug your headphones right into the DI4. You can hear your mix in total isolation without making a sound on stage. It prevents chaos.
Okay, so it solves both problems. The external connection and the internal monitoring. Let's really drill down on the specs that make this a professional grade unit, not just a convenient gadget. Let's talk about the numbers that prove the audio quality.
We're moving beyond just connectivity into actual fidelity. First, look at the frequency response. 20 Hz to 20 kHz, 0 dB to -2 dB.
So, ruler flat.
It's clinical performance. It confirms it handles the entire range of human hearing without coloring the sound, without rolling off the bass, or losing in that glassy high end from a synth.
It's just preserving the integrity of the original signal, which is all you want from a clean DI stage.
Yeah.
But the next spec, the noise performance, That's the one that really signals quality to me.
Yes. The total harmonic distortion plus noise, or THD plus noise, it's listed at 0.00008%, typical.
Okay, let's put that number in perspective. 0.0008%. I mean, that is just vanishingly small. What does that kind of transparency mean for someone using this live?
It means the unit itself is, for all practical purposes,
Right.
silent. It's adding almost zero harmonic artifacts or distortion to your signal, and that's so important because in a pro setup, you're fighting noise everywhere.
Right.
The wall power, the lights, the cables. If your very first component in the chain, the DI box, adds even a tiny bit of noise, that noise gets amplified dozens of times before it ever hits the audience. A component this clean stops the noise before it even starts.
But I wonder, is it too clean? You know, some engineers love a little analog warmth, a bit of saturation from a transformer.
Yeah.
By chasing 0.0008% THD, is DBX sacrificing any of that desirable character for pure clinical transparency?
That's a fascinating and, long-running debate in audio engineering. But for DI box, especially for keyboards and electronic sources, the consensus is almost always that transparency is king. The goal here is utility and preservation, not coloration. If a musician wants warmth, they'll get it from a specific preamp or an effects pedal before the signal ever hits the DI. The DI's job is just to be a neutral, reliable workhorse. Take the sound you made and deliver it cleanly.
That makes sense. You add character elsewhere. You want this first step to be zero distortion. And another T-spec for a 4-in-1 unit has to be channel separation.
Yeah, the interchannel crosstalk. It's specified as less than -90 dB across the whole frequency range. And that is essential when you have 4 independent inputs packed so closely together.
-90 dB means what exactly?
It means the sound from keyboard 1 is virtually inaudible, bleeding into the signal path for keyboard 2. So if you pan keyboard 3 hard left in your monitor mix, you won't hear a phantom echo of it leaking into the right channel through keyboard 4's circuit. It proves the internal design is really robust.
And it maintains that true stereo image. Let's wrap up with the physical details. Utility is great, but logistics on tour really matter. That compact half-rack footprint is a huge selling point.
Absolutely. It's 1 3/4 inches high, 8 inches wide, 8.5 deep, and it weighs just under 4 pounds. The ease of just sliding that into a touring rack is massive.
And the power supply is built for global use, which reflects that professional intent.
Yeah. It takes both standard voltages, 100, 120, or 200, 240 volts AC, so it's ready for international touring, and it's all backed up by a 2-year DBX warranty.
So to bring it all home for you, the value of the DI4 is really its mastery of efficiency. It gets rid of the need for 2 separate pieces of gear, the DI rack and the monitor submixer, by just merging them perfectly into one little box.
It solves 2 huge stage problems at the same time. It converts 4 unstable, unbalanced signals into professional low-impedance XLR feeds for the engineer, while also giving the musician a totally customized personal stereo mix with panning for their own monitoring.
And all of that while guaranteeing really exceptional audio quality, backed up by those, almost absurdly low distortion specs. It's the ultimate utility player for the modern electronic musician.
And that low noise figure kind of brings us to our final thought. If this one single component can produce sound with 0.0008% total harmonic distortion, which is just the definition of clean, that sets an incredibly high bar for the start of your signal chain. So now think about a complex stage setup. 100-foot snake cable, dozens of connectors, amps, a big house mixing console that has its own noise floor. If this one clean component adds almost zero noise, but the rest of that system adds its own subtle interference, how much of a difference does choosing that one clean component actually make in stopping that noise from creeping in and degrading the sound the audience finally hears? It makes you really think about where the weakest, noisiest link in your entire audio chain might actually be.